Area of a triangle. The area of a triangle with vertices or corners 0, 0, x1, y1 and x2, y2 is given by the following formula. So the area of the triangle is equal to half times the modulus, so these lines here mean modulus, which means that we take the positive value. So if we had -5, we would take it to be 5 and so on, of x1 multiplied by y2 minus x2 multiplied by y1. So 0, 0, the origin, must be one of our vertices. And the other two vertices or corners are x1, y1 and x2, y2. It doesn't matter which way you label these, so long as one of the vertices is 0, 0. Notes, number 1. The modulus symbol, so these two lines, is included to make sure your answer is positive. These lines represent modulus, they also represent length or distance, and we can never have a negative length or distance. Therefore, if the above formula gives a negative answer, simply ignore the negative sign. So for example, half times the modulus of -10 is equal to half times positive 10, which is 5. And this makes sense because we can never have a negative area. The area of this triangle must be positive. Number 2, if none of the vertices is at the origin, so is at 0, 0, simply select one of the vertices or corners and map or move or translate it to the point 0, 0 by a translation. Then apply the same translation to the other two vertices. So whatever translation you apply to make one of the corners or vertices become 0, 0, you must apply the same translation to the other two vertices. And you end up getting your x1, y1 and x2, y2 points, which you can then sub into your formula. Number 3, to find the area of a quadrilateral, which is a four-sided figure, divided into two triangles. The diagonal of a parallelogram bisects its area. And to bisect something means to cut it in half. Find the area of the triangle with the vertices -2, 1, -4, 9, and 3, -6. Well, hopefully first of all you notice that none of these points, none of these vertices or corners are 0, 0. So we have to choose one of them, it doesn't matter which one, and translate it to the point 0, 0. So we're going to go with the first one here, which is -2, 1, but it doesn't matter which one you do. So we're going to map or move the point -2, 1 to 0, 0. So how does -2 get to 0? So -2 and 0 are our x values. So how does -2 become 0? Well, we had to add 2. So you're adding 2 to your x value. And how does 1 become 0? So there are our y values, 1 and 0. How does 1 become 0? Well, we're subtracting 1. So we subtract 1 from our y values. So -2, 1 becomes 0, 0. So we did that by adding 2 to the x value and minusing 1 to the y value. Now we do the same to the other 2 points. So -4 plus 2 is -2, so we're adding 2 to the x value. And 9 minus 1 is 8. We're minusing 1 to the y value. And then we do the same. We take the 3 and we add 2 to get 5, adding 2 to the x value. We take the -6, we minus 1 to get -7. We're minusing 1 to the y value. Then we label our points, x1, y1, x2, y2. So x1 is -2, y1 is 8, x2 is 5, y2 is -7. Now we use these points and we use our area of a triangle formula. So our formula is a half times x1, or the modulus of x1 times y2 minus x2 times y1. Remember, this formula is in your formula book, you don't need to learn it off. So x1 we swap for -2 with brackets, y2 we swap for -7 with brackets, x2 we swap for 5 with brackets, and y1 we swap for 8 with brackets. So minus 2 times minus 7 is 14. 5 times 8 is 40. 14 minus 40 is minus 26. But we take the modulus of this, we take the positive value of it, so we use 26. And a half of 26 is 13. So the area of our triangle is 13 square units. Note that sometimes we are given the area of a triangle and asked to find the unknown values of missing coordinates. We are given an equation in disguise, and we solve this equation to find the unknown values of the missing coordinates. Note, if we need to map one of the points to 0, 0, it is good practice to choose one of the known coordinates. A, 3k, 5, B, minus 2, 3, and C, minus k, 4 are the vertices or corners of the triangle ABC. If the area of the triangle ABC is 4 square units, find the values of k. So remember, if we need to map one of the points to 0, 0, so we need one of these points to be 0, 0, it is good practice to choose one of the known coordinates. So point A has a k value in it, so that's an unknown coordinate. And point C has a k in it, so that's an unknown coordinate. So we have to use point B, which is minus 2, 3. So we map the point minus 2, 3 onto 0, 0. So our x value minus 2, to get to 0 we have to add 2. So we're going to have to add 2 to all our x values. And our y value 3, to get to 0 we had to minus 3. So we're going to have to minus 3 to all our y values. So we add 2 to the x's, we subtract 3 from the y's. So 3k plus 2 is going to be 3k plus 2. And 5 minus 3 is 2. We already made minus 2, 3 become 0, 0. And then minus k plus 2 is going to be minus k plus 2. And 4 minus 3 is going to be 1. So 3k plus 2 is our x1 value. 2 is our y1 value. Minus k plus 2 is our x2 value. And 1 is our y2 value. So we're going to take our formula for the area of a triangle ABC, which is a half times the modulus of x1 times y2 minus x2 times y1. We swap x1 for 3k plus 2 with brackets around it. We swap y2 for 1 with brackets around it. We swap x2 for minus k plus 2 with brackets around it. We swap y1 for 2 with brackets around it. Next we multiply out the brackets. 3k multiplied by 1 is 3k. And 2 multiplied by 1 is 2. Then minus k multiplied by 2 is minus 2k. And then multiplying in that minus, we end up getting a minus times a minus, which is plus 2k. Then 2 times 2 is 4. And multiplying in that minus, we get minus 4. Then simplifying, 3k plus 2k is 5k. 2 minus 4 is minus 2. So we have half times the modulus of 5k minus 2. So now we have to find the values of k. So we're told in the question that the area of the triangle is 4 square units. So we're going to say the area of the triangle ABC is equal to 4. So this is an equation given in disguise. Now we worked out the area of the triangle ABC to be a half times the modulus of 5k minus 2. So we swap that for half times the modulus of 5k minus 2, and it's still equal to 4. Now to get rid of the half, we're going to multiply both sides by 2. So 4 times 2 is 8. So we have 5k minus 2 is equal to 8. So now we need to get rid of the modulus symbol. And we're going to do that by rewriting as 5k minus 2 is equal to plus or minus 8. We must include both positive and negative solutions. So we'll have 5k minus 2 is equal to plus 8. So 5k minus 2 is equal to 8. So 5k is equal to 10. So k is equal to 2. So 2 is one of our solutions. And then we'll have 5k minus 2 is equal to minus 8. So 5k minus 2 is equal to minus 8. So 5k is equal to minus 6. So k is equal to minus 6 over 5. So minus 6 over 5 is our second solution. So we're asked to find the values of k. They are 2 or minus 6 over 5.